The second discovery is that the laws of physics, the fundamental constants, and the initial conditions of our universe are fine-tuned to allow for the possibility of life. In my opinion, this is the most important scientific discovery of all time, and yet, surprisingly, few people know about it. Many books have been written about this topic, but this slide shows 3 that I would recommend. And in addition, this topic is covered in the book by Steve Meyer and in the book by the French authors that were mentioned earlier in the slides covering the origin of the universe. It turns out that the precise values of these constants and initial conditions are critical for the universe to support life in very fundamental aspects, such as the ability to have a periodic table of elements, the ability for chemistry to even be possible, and the ability to have stars or stars that burn at stable rates. For example, it could easily have been the case that the only element in the universe was hydrogen, or that no hydrogen existed, and then there would be no water, which is the only solvent capable of supporting life. It could easily have been the case for chemistry to be impossible within the universe. It could easily have been the case that all the matter in the universe was all located within black holes, or that stars and planets never formed. This is a timeline of some important events related to this topic. The second item on the list is very important because it was the first time that anthropic reasoning was used to make a prediction in science. In his analysis of the synthesis of carbon atoms in stars, Fred Hoyle realized that a special condition had to be true for carbon atoms to exist. His prediction was later verified experimentally, and that had a profound impact on him because the special condition depended upon a precise value of one of the constants of nature. He eventually changed his view from being a materialist to believing that there was a mind behind the universe. The fourth one on the list stimulated a lot of investigations into this topic. It's a presentation by Brandon Carter in 1973 that was later published in 1974. The fifth item is a book by Barrow and Tipler called The Anthropic Cosmological Principle, which I think was the first comprehensive book on this topic. To organize your thinking, you can separate the fine-tuning into several categories. The first is fine-tuning of initial conditions, such as the initial entropy of the universe, the initial energy density of the universe, the energy density of empty space, or the cosmological constant, and the fine-tuning of a hypothetical inflaton field if you're thinking about inflationary cosmology models. The second category is the laws and constants of physics, and the third category is the masses of fundamental particles. If you open any university-level physics book, on one of the inside covers, you'll most likely find a table of constants like this one, including constants such as Boltzmann's constant, Planck's constant, the speed of light, constants related to the 4 fundamental forces, the cosmological constant, the Hubble constant, values of the masses of the fundamental particles, neutrons, protons, electrons, etc. It turns out that the values of these numbers really matter. And if they were slightly different, our universe wouldn't be suitable for supporting life. I'll go over a few examples of this to give you a sense of it. There are 4 fundamental forces, and each force has a constant that determines its relative strength. Taking the electromagnetic force, for example, if that force, which impacts electrical charges, if that force were slightly weaker, electrons wouldn't be held in their orbits. If that force were slightly stronger, though, electrons couldn't be shared among different atoms. Either way, no chemistry and no life. The strong nuclear force holds the nucleus together. If the ratio of that force to the electromagnetic force were 2% higher, there would be no stable hydrogen. If that ratio were 5% lower, there would be few, if any, elements other than hydrogen. In either of those cases, the universe couldn't support life. The ratio of the mass of a proton to the mass of an electron is also critically important. It determines the characteristics of orbits of electrons about nuclei. If it were slightly different, again, there would be no chemistry and no life. Stephen Hawking cited this as one of the many fundamental numbers in nature, saying the remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life. The electromagnetic force constant, also called the fine structure constant alpha, is also important in relation to the production of carbon atoms in stars, and that process is discussed in more detail in Steve Meyer's book and also many other places. And it's mentioned here in this article in Physics Today. I used to be a member of the American Physical Society, and so I would receive this journal, Physics Today, and right inside the cover, there was typically an article highlighting a very important issue in physics, and this one caught my eye because the author is referring to this coincidence about the value of the fine structure constant in its relation to the production of carbon atoms. And he said this: it's true, for example, that the fine structure constant, alpha, has to be close to 1 over 137 for carbon atoms to exist. And carbon atoms are required for us to be here writing about cosmology. However, these arguments have nothing to do with explaining what physical laws led to this particular value of alpha. And then there's a section in which he referred to a recent theory by Stephen Hawking and Hertog on this topic. And he finished with the statement, "It sounds to me a lot like the despised fine-tuning." And I thought that was remarkable because scientists aren't supposed to, the word despised isn't really appropriate in a scientific context. Scientists are supposed to be dispassionate and unbiased, but clearly that's not the case. This slide shows 3 more examples. The ratio of the mass of the neutron to the mass of the proton is tuned to 1 part in 1,000, cited by Lewis and Barnes in A Fortunate Universe. The ratio of the weak nuclear force to the strong nuclear force is tuned to 1 part in 10,000. That's cited by Martin Rees in this article here, and Lewis and Barnes in A Fortunate Universe. And the ratio of the electromagnetic force to gravity is tuned to 1 part in 10 to the 40th power. That's cited by Paul Davies in The Accidental Universe. Fine-tuning of the initial conditions of the universe is even more astonishing. 3 characteristics of the cosmic microwave background radiation are remarkable. First, in all directions, the CMB has the same temperature. Yet radiation detected in opposite directions of the sky come from regions so far apart that light travel time between them exceeds the age of the universe. If these regions were never in causal contact, how could they have the same temperature? This is called the horizon problem. Second, the CMB lacks distortions that would be present if the geometry of the universe were curved. However, for the universe to be nearly flat as indicated by the CMB, The energy density of the universe must initially have been very, very close to the critical density, estimated as 1 part in 10 to the 60th power. This is called the flatness problem. Third, analysis of the development of the universe from the time of the release of the background radiation to the present indicates that the tiny fluctuations in that radiation, measured as 1 part in 100,000, are fine-tuned for the development of stable, long-lived galaxies. If those fluctuations were a factor of 10 larger or smaller, it's likely that there would be few, if any, environments suitable for life. The face value interpretation of these characteristics is that the initial conditions of the universe were designed, that they indicate an act of creation by a mind outside the universe. George Smoot, who won the Nobel Prize for the discovery of the fluctuations in the CMB, said it was like looking into the face of God. An idea called inflation has been proposed as a way to explain these finely tuned initial conditions naturally, and thereby avoid a philosophical or theological conclusion. The idea of inflation is illustrated on the left-hand side of this chart by the short period of very rapid expansion driven by a hypothetical inflaton field. The inflaton field is something that's only imagined, and it's very unlikely that it could ever be directly measured or detected. Inflationary theories may explain the horizon and flatness problems, and may also explain the ripples of 1 part in 100,000 in the CMB as quantum fluctuations in the initial state that were greatly expanded during the inflationary period. However, inflationary models themselves require enormous fine-tuning in the energy conditions that turn the rapid expansion on and off, and also in the precise timing of those events. So inflationary cosmologies don't avoid the fine-tuning of initial conditions of the universe. They just displace it. The fine-tuning of initial conditions in the standard Big Bang model and in inflationary models is reflected in this statement from Lawrence Krauss from 1998. He refers to 2 aspects. First is the flatness problem in the CMB data that requires the energy density of the universe to initially have been very close to the critical density. The second is that inflationary models imply a fine-tuning of the cosmological constant, or the energy density of empty space, to an even greater extent. He writes, which fundamental fine-tuning problem is one more willing to worry about? The flatness problem or the cosmological constant problem? The latter involves a fine-tuning of over 120 orders of magnitude. If the cosmological constant is non-zero and comparable to the density of clustered matter today, while the former involves a fine-tuning of perhaps only 60 orders of magnitude, if one arbitrarily fixes the energy density of the universe at the Planck time to be slightly less than the closure density. An up-to-date discussion of the different models and the fine-tuning involved in each is given in Steve Meyer's book, The Return of the God Hypothesis. The most extreme example of fine-tuning is the entropy of the initial state of the universe. The second law of thermodynamics indicates that the entropy of the universe always increases with time. So if one imagines going backward in time to the beginning, the entropy must have been much lower than at present. The highest entropy density of any object in the known universe is that of a black hole. Roger Penrose compared the entropy density of the initial state of the universe to that of a black hole to estimate how finely tuned that initial state must have been. He says the initial state of the universe is certainly fine-tuned, at least as precise as 1 part in 10 to the power 10 to the power 123. This slide has a link to an interview where he states this result. To summarize, I return to this diagram representing some ideas about the stages and events of the early universe prior to the release of the background radiation. The earliest phenomenon that can ever be measured, the background radiation, has characteristics that are absolutely remarkable and seem to be highly, highly fine-tuned. In attempts to explain this naturalistically and avoid a theological conclusion, scientists have proposed a series of astounding events prior to the CMB that can't be measured or detected, and that themselves require exceedingly high levels of fine-tuning. The inflationary models don't avoid the problem of fine-tuning, they just displace it. So the term Big Bang is actually very misleading, because to the uninformed person it gives the impression that the universe started in a random chaotic explosion. However, the origin of the universe is the very opposite of a random explosion. It's the most highly fine-tuned event that we've ever detected. More accurate terms might be the highly specified origin of the universe, or the precisely fine-tuned creation event. Finally, it's very important to keep in mind that ideas about what may have happened in the earliest stages of the universe are untestable, and so many would say they're outside of science. We've just skimmed the surface of this topic. A lot has been written and there are a lot of YouTube videos discussing this. Please see the books that were mentioned earlier, as well as this slide shows some websites that I recommend. The fine-tuning of the initial conditions and the constants of physics indicates that the universe is biocentric in its very essence, at the most fundamental level. This is also called the anthropic coincidences. You can search that term on the internet and find many, many examples. This discovery is not controversial, but scientists differ about the implications or the conclusions to make from this discovery. Paul Davies wrote that the really amazing thing is not that life on Earth is balanced on a knife edge, but that the entire universe is balanced on a knife edge and would be total chaos if any of the natural constants were off even slightly. This comes from The Goldilocks Enigma, which is one of my favorite books on this topic. But further on in that book, he goes on to state that he's philosophically opposed to the idea of a designer outside of nature. George Greenstein, an astrophysicist and an avowed atheist, wrote this: "As we survey all the evidence, the thought insistently arises that some supernatural agency, or rather agency, must be involved. Is it possible that suddenly, without intending to, we have stumbled upon scientific proof of the existence of a supreme being? Was it God who so providentially crafted the cosmos for our benefit?" But he went on to state that he rejected that possibility for philosophical reasons. Fred Hoyle was an astronomer. He was the discoverer of the fine-tuning involved in the production of carbon in stars through what is called the triple alpha process. He was originally a materialist. He coined the term Big Bang in derision and advocated for this steady-state theory of the universe for many years. But following the discovery of fine-tuning in physics, chemistry, and biology, he came to the view that there must be a mind behind it all. In 1982, he wrote this: "A common sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. Arno Penzias, who was one of the discoverers of the cosmic microwave background radiation, said this: "Astronomy leads us to a unique event, a universe which was created out of nothing and delicately balanced to provide exactly the conditions required to support life. In the absence of an absurdly improbable accident, the observations of modern science seem to suggest an underlying, one might say, supernatural plan." To summarize the second item on the list, it's a fact now that the universe is fine-tuned to an astonishing degree at the most fundamental level to allow for the possibility of life. Again, I think this is the most important scientific discovery of all time. Thinking now about the first two discoveries on the list, number one, that the universe, meaning space, time, matter, and energy, had a beginning and will have an end, and the laws of physics, the fundamental constants, and the initial conditions of our universe are fine-tuned to allow for the possibility of life. From these two discoveries, it's unavoidable that something really amazing has to be true. The universe came into existence from nothing, and the universe that came into existence is fantastically, marvelously fine-tuned to be functional and to support life. So something really amazing has to be true. What are the possible explanations? I think there are three. Number one is that there's a mind outside of nature that most people would call God, that explains or is the source of these informational discontinuities. The second is the idea that maybe there's an infinite number of universes, and if there's an infinite number of universes, the probabilistic resources are infinite, and so anything can happen. And so you could attribute the fine-tuned universe to that explanation. The third explanation is that a mind is behind the universe, but it's a mind within nature. That is, somehow our universe is a computer program, like in the film The Matrix. The concept of a multiverse is now part of pop culture because it played a big role in a recent Spider-Man film. But the concept has its origin in physics, in attempts to explain the fine-tuning of the universe. I really like the book The Goldilocks Enigma by Paul Davies. He's a great writer and very good at explaining complex topics in ways that makes them accessible. He's an expert in particle physics and also in the fine-tuning in physics. But also, in addition to the science, in this book he acknowledges the philosophical side of the debate. And that's a little unusual for a scientist. I really appreciate it. Regarding the multiverse, he says this: "It represents a huge departure from the way we normally do science, and many scientists are aghast at it. But it may be the only answer." He says it's a huge departure from the way we do science. To understand that, think about this. Using a hypothetical multiverse to explain the fine-tuning is the same as using the multiverse to explain the car on the beach. How do you feel about that explanation? Later on in these presentations, we'll see that another highly regarded scientist, uses the multiverse to explain the information processing system that is at the core of all living things. We would never use a multiverse to explain the car because we know that cars are made by people. And also, we know that waves rolling up and down on the beaches of the world have never produced anything like a car. But it's the same absurdity to use a hypothetical multiverse to explain the fine-tuning or the information processing system at the core of life. And, he says, it's not the way science is done. The design perspective is that from our experience, we know that informational discontinuities always come from a mind. That same logic applies to cars, fine-tuning, life, or other informational discontinuities. But for fine-tuning or for life, the real issue is that materialism is at stake. And for some people, that philosophical issue changes everything. Notice that at the end of the statement, Paul Davies states that the multiverse may be the only answer. But clearly it's not the only answer. He says that it's the only answer because he's a materialist, and so the possibility that a mind outside of nature may be the cause of the fine-tuning is unthinkable. So it's very important to understand that the philosophical side of this is crucial. And it's not about science versus religion. The third possibility is that our universe is a computer program. This might seem crazy to you, but it's an idea that's taken seriously by quite a number of scientists. And the idea was highlighted in an article in BBC Earth in 2016, and in fact, it was listed as one of the best articles of that year. This article points out that the basis for this idea that we might be a computer program is the fine-tuning of the universe. These paragraphs come from that article, and I'll just read them. Some scientists argue that there are already good reasons to think we are inside a simulation. One is the fact that our universe looks designed. The constants of nature, such as the strengths of the fundamental forces, have values that look fine-tuned to make life possible. Even small alterations would mean that atoms were no longer stable or that stars could not form. Why this is so is one of the deepest mysteries in cosmology. So this explanation recognizes the fine-tuning of the universe as an informational discontinuity that points to a mind. But if the universe is a computer program, then everything we do and experience must be algorithmic. Personally, I don't think that's the case. I don't think I'm a character in a computer program. So something really amazing has to be true. Two of the three possible explanations recognize that the fine-tuning of the universe is an informational discontinuity that points to a mind. The other explanation has many problems, and these are discussed in some detail in Steve Meyer's book.